yeah, let's see what's in the box. And this is the PCBs for my Retro Chip Tester Pro. And this package is ordered directly from the makers of this kit, the 8-bit museum in Germany. They have supplied us with 2 warning notes. The first is that there is a misprint on the PCB for 1 resistor value, and the other one is that the fuses on the 80 mega has not to be set because I already ordered this pre-programmed with the latest firmware. So this small board here contains the voltage regulator board, and there is also a small USB connector inside here that was ordered alongside. And this is the PCB, and it's safely wrapped in a good anti-static bag. Yeah, and here we can see that the 80 mega is already placed. There is a crystal and there are 2 capacitors on the board already. And the board is neatly laid out, everything is labeled and should be really easy to populate. The quality of the board we have to see when we start soldering on, but so far it looks good. The real beauty of the documentation for the Retro Chip Tester Pro is this interactive layout of the boom coupled direct to the outlay of the PCB. And as an example, the first components I'm going to place are these diodes here. And when I click on the diodes here on the schematic, they pop up here in the boom. And the same the other way, if I want to find out where these chips go, they light up in the PCB layout here as the resistors. And these are all 407 ohm resistors. And this differs from earlier versions of the Retro Chip Tester Pro that had this as 1K resistors. But to be able to test a wider range of logic chips, namely the 74 chips that has not the LS or other power saving parts of the family. This is a real time saver. This is available for all versions of the PCB, I think, but my version is a K version. And this was updated sometime in October in 2021, but I do think there are some small changes done after that. And one thing I have to mention is that I have also placed all optional components. That means that I have all options for power placed on the board at the same time. And you don't really need to do that, because if you have the extra power conversion board that I have, you don't really need to populate all these components here, and you don't need to populate all these sockets. So there is a lot of redundancy in the way they power this device. And instead of using the power conversion board, you can connect the power direct to these headers over here. And these are also being mounted now on this board. And one more thing is that I ordered the board pre-programmed and pre-soldered with the 80 mega chip. And then the crystal also is put in place, and these 2 small capacitors here that does the loading of the crystal. But strangely enough, the resistor that stands to also load the crystal was not placed, so maybe that is not needed after all. It's just an extra precaution for the oscillator to spin on the right frequency. But first we are going to place these diodes, and these diodes are all 5.1 volt Zener diodes. That stands here probably to protect the circuit around the board for getting higher voltage. And as usual, most of the work with placing in these components on the board is not the soldering or anything, it's the bending of the legs on the components. And here we do have some issues. These diodes is glass covered, and you can't bend them too close to the glass. You can risk that you actually breaks the plastic or the glass. So I do have to find a way here, but I do find a way to bend them, and this is a thing we often see with modern constructions, is that they put too small and narrow space between the legs, so you can't bend the components careful enough. But after I've got the hang of this, it goes quite fast. Yeah, and then it was time for these resistors. You can see here that there are 54 of them. And I ordered these from DigiKey as 54 units, but they clearly have miscounted because I only find about 40 in the package I got from them, even though it says 54 on the package. But on to the board again. And it's a bit of the same with these resistors. I have to bend them totally close into the body of the resistor itself, but on a resistor that's really not a big problem. So here it's just bending away and placing them as fast as I can. With diodes you of course have to put them the right way for everything to function, but I do try to keep all the resistors the right way too, so that you can actually read the color coding on them afterwards. The graphics representation is of course a huge help when you should place out the components. And then I was all out of DigiKey's finest resistors, and I do have to supplement with my own China AliExpress supplies, and these are actually much easier to bend. The legs are so much thinner. But I found this to be rather okay quality, so nothing bad against buying these for a normal hobbyist. But as you can see how much I trust them, I do make a control measurement with the ohm meter to check that they actually are 470 ohms. And by now it's starting to get a jungle underneath the board, so I will try to take a round with the soldering iron and get to clean up and cut the legs of the components we already placed. And as I mentioned before, it's very important not to cut the legs of the components too close to the PCB, so that you cut off most of the soldering. That's not a good idea. And you also have to use pliers that leads the force outwards from the board. If you use a plier or put the plier upside down, you will actually push this force of the cutting down towards the board, and that can actually destroy the soldering. I always try to start with the components that there are most of on the board, and of course the normal way of doing this is to take the lowest components first, so that you can actually put your board upside down and solder each components in an easier way. I don't always follow that rule because I know all the ways around that, but it's a very good rule to have all the similar, where there are most components of one sort, and place them out first, because then it's much easier to maintain your stack of components, and you will narrow down to see where your next step will be. So now we take these diodes. It's a 1N5817. I think it's a Schottky diode. And these are diodes that host in a black plastic hose, and I do think that these two should not be bent too close, but with the pliers I managed to find a way to bend them so that they look quite good and you don't damage the plastic. And here I actually missed one diode, and that's quite easy to do, and you will always catch up on them in the end. And now it's the 4.7K resistors that I should place, and this was super small, and I also ordered them from DigiKey, and I do take a control measurement on these because I can't read the color code, so small are them. Yeah, as most of the process is the same as with the other components, I won't stop and comment on every one of them. So I just speed up the movie and we place and solder the components, and I will stop and comment when there are something interesting happen. Yeah, when you inspect your work and if you see some components that's not laying flat to the board, it's just to push them down while you're heating the solder joints and they will fit right into place. Yeah, and here I just remember that the capacitors for the crystal already was in place. Yeah, and now it's time for some small signal TO92 transistors to be put in place, and we have to remember that these have 3 legs and the PCB is marked with the orientation of the housing of the transistors, so they are quite easy to place on this PCB. What you do have to remember is that the space between the pads for this transistor is rather small, so it's easier to get some solder blob there. Or do as I did, I cut 2 legs at the same time with the pliers and then I put the legs together. I luckily discovered that at once and used just the pliers to cut the legs apart again. Yeah, and there's a bit of a fiddling with these LEDs because I've decided I won't put them straight down to the PCB. I will have some air between to lift them somewhat, and since I didn't bother to do any spacer or something, I just have to eyeball it like so to get them straight and get them about the same distance from the PCB. The socket for the ULN 2003 is easy work. We just put a plastic pad under to keep it straight to the PCB when we solder. And these screw headers are really not necessary. They are for manually supplying -5 volt and 12 volt to use if you don't have the power regulator board. There are 4 long switches for controlling the different aspects of the tester, and there is 1 reset button. That's the low one that we solder in first. And here you must not use too much heat because the hoses of the switches are only plastic, so they melt easily. Yeah, the rest of the TO92 transistors I have to solder in is the common BC547 NPN transistor. Yeah, and this first here is an ordinary 7805 linear 5 volt regulator, and this regulates down the voltage from the barrel jack and down to 5 volt. And this is stated that you should not have more than 9 volt here, otherwise you will require cooling on this regulator. Yeah, next up are the MOSFET power transistor in Q31, and I think this is supposed to switch in and out the VCC supply voltage to the socket or something, but I'm not sure as I don't have a schematic for this construction. And then it's the barrel jack for the power input. Then I fix various headers that's supposed to connect the DC power module and the display. And as you can see, I don't bother to line these up at first. I solder 1 pin and then I look at it and straighten it up and just heat that point again and then solder the rest. This is a much faster technique than lining anything up and use blue tack or something else to fix it while you solder. The guys at the 8-Bit Museum has been kind enough to supply us with a volume knob for the buzzer on the board. This PTC fuse is not the exact model that was stated in the boom, but I do think it will work. I don't think it's very critical for the function of the device. The 2-pin headers can be a pain in the ass to solder straight onto the board, and I do use a jumper cap that is slightly higher with this finger handle or what you call it, and push this down to the board so that the pin header will be pushed against the board when I solder. And here we have some forgotten capacitors and another pin header, and then I see that I've ordered the wrong trim pot for the contrast on the display, but I will find another in my parts bin and solder that in. The value is a rather standard 10K liner pot. there are 3 bodge wires that need to be connected on this board, and I try to make it simple for myself by using link wires for a breadboard to just find some lengths that's about suitable, and I just solder them in. And here I also found a suitable header for the SD card expansion board. And with the SIF socket I use my normal technique with soldering in 2 legs, and then I push the socket towards the board, and then I solder in the rest of the pins. The orientation of the SIF socket is an important issue, and you must not place this the wrong way around. The LCD module is connected with the pin headers, and I now try to solder these on. It's not the easiest task because I don't have a continuous row of pin headers for this. And also the solder didn't stick very well on the pads on the LCD module. Of course I could have cleaned them, but I'm so used to just using this good solder wire with a good flux core. And now it's time for the power converter module, and this contains a DC to DC converter to make the 12 volt and the -5 volt. It also plugs straight into the board via pin headers, and I use components from my parts bin, and that's why I test these cheap China capacitors to see if they are about 100 nanofarad. Yeah, the rest of the build of the power regulator module is quite uneventful and just uses standard components that we have seen before. It's nothing special, except that the power supply module that I'm using here, there are room to use some other modules, but this is a ready encapsulated module bought from DigiKey. Yeah, when it comes to soldering the pin headers that should connect this to the main board, I take the dark path and I just put the pin headers in the sockets and put the board on top and solder. And of course, if you use too much heat, this is not a good solution, but if you are careful, it's a very easy and good solution. There should be some spacers between the 2 boards here, but the power conversion board I won't bother because it's a very tight fit with this plug. But I do have to fit something underneath the display board as the connector is in one corner of the board. Yeah, and now our little construction here is coming together just nicely. And what we can actually see here is that most of the places on this PCB is actually filled. And what's the difference between the last time you looked at this board? It's these 2 relays over here. And I don't have the right kind of relays. I have ordered them, but there were kind of delay in the delivery time. And these relays are rather small form factor, but they are dual pole, dual action relays. And they're kind of the same as the Commodore 64 power switch, really. They have double set of contacts, and the contacts is in one position when the drossel and the relay is off, and one switches to the other position when the relay is activated with 5 volt on the drossel. And what you can see here is this relays is rather raised from the board. And I've just soldered some length of wire and put the relays on top. And my relays here are surface mounted really, but I just soldered this to the legs. It's a working solution, but it's not looking very nice, and I will replace these when I got the proper relays. Yeah, and before we can do any testing, it's wise to do some extra cleanup to avoid short-circuiting something underneath the board. And as you can see, there is a lot of metal clippings from, yeah, even a rather small project as this. And then I discovered that somehow I have managed to misplace my ULN 2003 A ships. And I specially ordered those, 2 months ago. And I know I got them, but no, I really can't find them. And normally I pack the components I got, I pack them and sort them at once, but somehow these must have been misplaced somehow. So I will not be able to test this, I will have to wait for this ship. And of course I can probably test that the device boots and so on, but we will not be able to test any ships without this. And this ship is a Darlington, I think it's a 7-pair Darlington driver. That's normally used for stepper motor driver circuits and so on. But otherwise, this build is complete from an electronic view. Of course, from a mechanical view, we have to make some kind of, I don't know if I'm going to make a case or I'm just going to make some stand that will keep this secure in a better way. This display is a cheap Chinese AliExpress part, so we have to see if this works. I did order one other display with a green backlight, and also I did destroy this USB port, but I think it's just an option because you can choose to power supply this from the barrel jack or the USB, and I also think that you can power it from this USB B port. So now we have to just wait for this part to arrive before I can get any further in this project. But I can't wait to test the basic functionality to this for another week or so until the ULA 2003 ship arrives, so I will just power this on now. And as you can see, the lights, they light up, so we have all the power supplies okay, and there is backlight in the LCD, but no writing on the screen. So I will try to adjust the contrast in the LCD to check, and what do you know, there you have writing on the wall. And I must admit that I have read little about the operation of this device, but I do think that this is a valid startup picture. Yeah, I think I will try push on the reset button to see if we get back on the same screen, and we do. Yeah, I saw in one of the PDF that there should be some kind of self-test in the menus here. Let's try, and I think this is it. It went out with an error, and that's not unexpected. Yeah, let's hope that the test is due to the ULA 2003A that's missing, and I will run a new test when I got this ship, and that's sometimes during the next few days. Yes, that was as far as we got in this video. And we do have to wait for the ULA 2003A ship to arrive, and that will be in a couple of days. But I'm out traveling next week, so that probably will be in about a week or so. And I do hope to work on another C64 Resurrection video in the meantime. But I did actually hope to use this retro ship tester in my next C64 Resurrection video, so we have to see about that. And as you can see, I'm in the web page of the 8-Bit Museum, DE, that has made this device. And I do think it's a great device, and I've seen it on other YouTube channels, so I've seen this in use. And I do think that the device is very good, but one shortcoming of this is I can't find that they have released the schematics for this. And of course it's their intellectual property, I can see that they want to keep this close to the chest, but think about all the wonderful computers that we are working on in the retro community, and if this device breaks in 10 years, 20 years, how will we be able to repair them with no schematics available? So available schematics, I think it's the heart and blood of the retro community, so I do advise them to release at least the schematics for this. The list of devices that's supported on this device, it's huge. And I do think that I will build some of these adapters, the SimZip module adapter, and some of the old RAM chips will be nice to have. And some of the EEPROMs from early on will also be valuable to be able to do a direct dump of. And as you can see, they've made available a device to dump cartridges from the C64, the VIC-20, and the VCS 2600 Atari game adapters. And of course, on some of the adapters for the C64, there are additional logic that might not make it possible to dump the contents per se. But at least all the game cartridges, you are able to do this. And you also have adapters to program some of these chips. As you can see, there are lots and lots of chips in the 74 range, in the 4000 range, and all the other ranges of Michelin's chips that are I/O chips and other chips that's used on old PCs and whatnot from the 80s and 90s. So I'm really looking forward to make use of this device, and I was planning to use this device in my next C64 Resurrection video, but we might not be able to do that. I plan to release another Resurrection video after next week or so if I'm able to do some footage this weekend. So, thanks for watching. I hope you enjoyed the content. Please hit like and subscribe if you want to be notified when we post new videos. See you in the next one.